Hello and welcome to Lab Books in Your Classroom as part of our Coffee with the Consultants. Before we get started, let's take a second and acknowledge the land that we're all gathered on here this morning. The Creator gifted us with this land that we're blessed to care and share for together. Calgary Catholic School District acknowledges that the land we gather on, Mohkinstsis, is the ancestral territory of the Siksika, the Siksika, the Kainai, the Piikani, and Amskapi Piikani. We acknowledge all First Nations and Métis of Treaty 7 lands, the Tsuut'ina, the Ithqabay, which include Bearspaw, Tuniki, and Goodstoney. The Calgary Catholic School District commits to advancing reconciliation guided by truth, respecting treaty laws, and humbly walking along with First Nations, Métis, and Inuit. We all recognize who live, work, and play on these lands and who now call this place home. Okay, so today we celebrate Blessed Chiara Badano. She was a young Italian girl who had hoped to enter religious life, but unfortunately died of cancer at 19 in 1990. She's the patroness of teenagers and youth, and I thought that is just kind of a good example as for the kids that we're teaching. Okay, so today we're talking about lab books, and of course, when we talk about those kinds of things, they're embedded in our priorities. Of course, hopefully today the one we're talking about is student success, because we're really thinking about ways that we can create optimal student-centered learning. So today what I'm hoping to cover is what are they anyway, why we use them, how we use them in elementary, maybe some ways we can use them in junior high, and how we can use them in high school. So a lab book and a field journal, kind of the same, kind of different. Lab books are primary records of research. They're kind of what we see when we do an experiment. They record data, observations, and reflections for after the experiment. Field journals, they tend to be things that we take outside. They're used to record findings and observations. And sometimes students can collect things like fallen leaves or those kinds of things. They often include sketches, diagrams, questions, and reflections. And what's good about these is when they're all together in one place, students can kind of go back to a place they've already been at to see if there's any seasonal differences. So what are we seeing in elementary? So I kind of bring this up is because this is what our students are doing right now as they are moving through the grade 6 new curriculum in science. So students will have had exposure as they move into junior high in the fall with lab journals, with these field journals. So we should harness that and use them more in junior high. So this is what we're seeing. We are seeing pictures, words, and numbers. This is a student who's taken it outside as a field journal, made a sketch, made some observations. It has included numbers, has included a scale, and then has some description. So it's kind of this spot where everything is being recorded. We encourage our students to take metadata information. So that is things like time, weather, those types of things, because they help us understand the seasons. So as we move into that junior high and high school realm, the question really that needs to be answered is why would we want to use like a lab notebook or a lab journal? So I think the strongest piece of evidence or the strongest sort of thing I can say is it's student-centered. It's created by the student. The students can then look for patterns over time. It's a permanent chronological record of the investigations and lab activities that they've done. It also establishes that the labs are integral to the learning process and not just an activity that they do, hand in and forget about, and then they look at the grade, whatever. It's a reflection of learning, or at least that's the hope, and it helps organize the thoughts and provides a record of work that's completed, and then hopefully a student can come back to it later. So I kind of thought about how to organize this, and I thought, well, we gotta I think it's important to scaffold using a notebook for investigations for our students. And so one of the ways I kind of thought about doing that is by leveling it. So I created or kind of thought about this and thought, well, maybe we could create like a 3-level thing. So we want all the labs in one spot. They need to be taught explicitly, and we can level them by having level 1, 2, and 3, where level 1 is teacher guided and teacher created. It's very heavily scaffolded. So the teacher's done most of the thinking. They've organized the title, they have the prediction or the hypothesis, maybe they've laid out the, of course, they've laid out the procedure, maybe they've laid out exactly how they'd like the results collected, etc. Level 2, we remove some of the scaffolds, but many still remain. It's very, very much teacher guided, but it's becoming more student created. And then level 3, it's very teacher supported, but it's more student created. Students are doing most of the thinking. They're figuring out how they want to collect the data, what their tables might look like, where they're going to organize all this information that they're now collecting through their investigation. So here's an example of level 1. So as we see in level 1, this is the teacher created student, teacher guided and teacher created. And we see everything is sort of listed for the student. There's the problem, the prediction is laid out nicely, the procedure is given, the methods, and all of those pieces are required are given to the student by the teacher. Essentially, a teacher could like run this off and just have the students staple it right in their lab notebook. I do have this online, so the QR code that you saw at the start will lead you to the slide deck, and you can just click on this and open the lab. So again, the results table is laid out for the student. The student will get with a partner, collect some data, and then all of the data will be pooled as a class. And again, those data tables are set out by the teacher. A student is just filling them in, right? Very scaffolded. It's a very clear expectation of what comes next. There's lab paper. You can see the gradations for the grid paper is provided for the student. Now, depending on the strength of your students, maybe the scales are already put in, like 0, 1, 2, 3, or 5, 10, 15, whatever the case may be, depending on how much explicit graphing teaching has already happened. So for the conclusion on a level 1 lab, the reflection is based on questions. So students are just responding to questions, and the questions are set up such that they help the student make a conclusion about the lab. So, we were looking at biodiversity, which is in grade 9. One of the big ideas in that comes from the curriculum is some traits are continuous and some are discrete. And so we target those questions, like which are discrete, how do you know? Which are continuous, how do you know? And so we prompt them by saying to the student, well, look at the graphs you made. How many points are on there to help them figure out which is which. So level 2 is teacher guided and student created. So the teacher is providing the problem and the procedure and a skeleton for the data collection. And maybe a sentence starter is given, helping the students organize their lab pages. So some of the scaffolds still remain, but a few are now being taken off. So what is the student really supposed to do on their own? Well, they're supposed to make their own predictions and record their own results and do their own analysis and interpretation. So it seems like a lot, but again, we do have a lot of those scaffolds still in place to help support the student. So if you look, very similar to what we saw in level 1, the problem is there, but now there's no sentence starter for the prediction. It's just, predict what you might happen. So looking at the problem, which of those traits are discrete, which are continuous. The procedure is still intact. You might want to, depending on how the class is set up, the teacher might read the procedure with the student or just give it to them the night before so that they can read it, or whatever the case might be, but nevertheless, it is provided. And then what does it look like in the student lab book? Well, the prediction is kind of is written directly into the lab book, and the procedure is probably just glued in. So if we just kind of take a look, how did the results differ? Well, the results for the partner piece look a little different in that for level 1, the scaffold was given. The table was given to the student. All they had to do was fill it out. For level 2, we might say, you know what, make up your own data table and figure out how you want to fill it in. And that would go directly into the lab book. The class data, though, likely because it becomes then a little bit more complex, we might scaffold that for our students and give them a table, which they can then cut out and put in their lab notebook. And so they would just fill it out as the class data became available on likely the whiteboard. So the scaffolding would look like this. We'd ask the students to label the X and Y axis, give the title. We might say, again, I wouldn't, depending, the gradations are there. The student might fill them out on their own, 0, 2, 4, 6, or they might be given, ultimately as a teacher, decide how you want to do that. And then, so that is what a level 2 lab scaffold might look like in a junior high classroom. The conclusions are also based on reflection, maybe a little fewer hints given, maybe an extra question added, so a more discussion type of question to help kind of get the students to think a little bit deeper about what they had just completed. So level 3, this is teacher supported, but it's mostly student created. Here, the teacher provides the problem and the procedures. The teacher might provide headings, so like might remind the student, okay, don't forget, I expect to see a prediction / hypothesis. I want to see all your data, so please collect your data in an appropriate table. I want to see a conclusion, that kind of thing. I'll be looking for analysis of your results. This is the sort of the high school model, especially when students get to grade 11 and 12. So the problem, maybe you give to the students on the whiteboard and they kind of jot down in their own notebook. The prediction, you leave blank. The students would then, with your help or not, come up with their own prediction. Maybe they can talk to their classmates to sort of figure that out. But here's kind of where the heavy lifting comes in. Students now have to decide how they're going to collect their data. So they have their own observation chart. If you've noticed, I took this from another student. They've got centimeters above height and above foot length. So that's good. Again, cues us to think about how we're going to eventually analyze our data and how we're going to put it on our graph. Students will collect raw data for height, and then they'll make a decision how they want to organize it. So again, in a classroom, this might look like once students are completed with their partner work, they just go to the board and write out the heights. Once all the heights are there, we could take with the help of the teacher or just in their groups, students might take a look and say, well, how should we organize these? I have heights that range from 140-ish to 181 looks like is our highest. So how are we going to break up those gradations? Are they going to be by 5 centimeters? Are they going to be by 4 centimeters? Maybe by 10, depending on how they want to do it. And so that's that cognitive lifting that students will engage in to help them figure out how they want to organize their data. And so now the expectation for the analysis would be graph paper is provided. Maybe kids have their own, but you as the teacher will hopefully have some that you could give it to your students. And now they start to plot the data that they collected and organized into a table onto their graph. They have a title, they've labeled the axes. Now along the bottom, they figured out how they're going to do their numbers. So we've got 140 to 145, 146 to 150, 151 to 155, etc., etc. So for level 3, the conclusion really is more of a true conclusion. It's really responding to the problem. So you don't really necessarily need a series of questions. It's more like, well, as you look at your data and you think about the problem at hand and the predictions you made, like what did you find out? So which traits are discrete and continuous based on your data? This is a good chance for us to ask our students to think about the procedure. What changes should the student make? Why or why not? Students might then come up with ideas like, well, maybe we shouldn't have done it. Maybe we shouldn't have measured things in centimeters. Centimeters are too small. Or alternatively, they might say, oh, it's a good thing we chose to do centimeters because they're nice and small so we can get more accurate. So those types of things come up in the conclusion piece. So again, just in a little bit of research that I was doing, this is kind of where we're at in high school. Or sorry, I should say in secondary, students are expected to kind of get to problem and procedures where we're only providing them that. As they start doing lab investigations, we do need to give them everything, really kind of explicitly teach that and scaffold it and walk the students through it. And by the end of grade 12, the expectation is that giving them a problem and some procedures, the students will be able to figure out how to analyze their results and then interpret them. So here's the thing, if you just look over on the right side of the chart here, because we're in the process of teaching students, generally we know the outcome. Unlikely, probably the kids do as well. And so I know it's really hard for them and us when they're like, well, is this the right answer? Does this look right to you? It's hard for us to be like, yes or no. I often will just say to students, well, okay, let's go back to your procedure. Are you sure you did it correctly? Is there something you may have missed? Are you sure you didn't miss anything? That type of thing, if I notice that maybe they've gone a bit awry. So when we keep talking about lab books here, some housekeeping things we can't forget. Lab notebooks have, and they must have, a table of contents. There's a nice template here. Again, if you click on it, you'll have it in your Google Drive. All of them should be numbered. Page numbers should be numbered. The date always should be up there. And any other metadata you might find important, air temperature, weather condition, I don't know. But they should be in chronological order. Is it okay to repeat a lab a month later? Absolutely. Do you think it'd be great to, especially some of our high-hitting labs that really employ a lot of skills, is it good to redo them? Why not? It's great. And it would be an interesting sort of study then to see how the kids did from their first time around. Ultimately, I think our goal is to move away from unrelated or unconnected labs or activities that kids are doing to a collection of learning. Really encouraging our students to do more of the cognitive lifting, to think about the data that they're collecting and organize it in an effective way and think about how they want to analyze it. And, of course, when it starts, we do give kids lots of sheets to fill out, but we do want to move them from gluing to doing. Less gluing into or stapling into their lab books and more just directly jotting things into their lab books. And so here's some resources. This is a really great site from my elementary colleagues on journaling and how they use it in elementary. As always, if you have any questions, please reach out. Thank you so much. Thank you again for joining. If you have any questions, please reach out at my email at any time. Thank you.